Hey folks, Mr. Nickel here. Just wanted to give you guys a quick little interesting video on passive and active transport using a diagram that I think is super interesting. So here, what you can see on your screen, this is the reaction mechanism or the reaction pathway for insulin secretion. So it looks really confusing right now. We're going to focus mostly on this diagram over here. We won't focus too much over on the right-hand side of information there. All right, so to start things off, just to quickly describe what diabetes is to you. Some of you probably know somebody that has diabetes, either type 1 or type 2. Odds are you know somebody that has type 2 diabetes. So what type 1 diabetes is it's an autoimmune disorder. So auto meaning that it happens automatically, immune that it has relation to your immune system. And what it's caused is it's caused by the body rejecting the insulin that it actually is producing. And so the body ends up attacking the pancreas and basically trying to destroy it. It's a really, really terrible disease. But basically it leads people down a pathway where they cannot produce insulin. And so those are the individuals that need to get insulin shots regularly. Type 2 diabetes is more likely what you're familiar with. Type 2 diabetes is often caused or rooted by obesity. And so type 2 diabetes is insulin resistance. The body's still able to produce insulin, it just resists the insulin that it produces. It's sort of like if somebody says something to you 30 times over and over and over again, probably about by the 5th or 6th time, you're going to start listening a little bit less. Even if someone's really screaming and shouting it at you, if it's the same statement, you're going to stop listening at some point. And that's sort of what your cells are doing, that they're getting just overwhelmed with the amount of insulin that's being produced. And you got to just keep increasing the volume or increasing the amount of insulin so that they're hearing you and acknowledging, or that the cells are acknowledging that there's insulin there. So as you can see on your screen here, this is the diagram. And so what happens in this little diagram here is that the whole process, as you can imagine, starts with, where's my little mouse? Oh, it's all the way over here. Starts with glucose. It starts with sugars. Glucose obviously being what your bodies want to break everything down into. It's the best sugar for your body. Those are going to enter the cell through a transporter. So we have a type of transport that's happening here. And what's happening is glucose is going to be at a really high concentration in the rest of the body. We're looking at specifically a pancreatic cell here. And so what we'll end up seeing then is that glucose is going to move from an area of high concentration to low concentration. And so this then would be passive transport. Glucose moving from an area of high concentration to low concentration. It'll be a lower concentration down in the pancreatic cell. What happens next is something called glucokinase is going to bind a phosphate to the glucose. And basically what that does is it locks it into the pancreas and says, you can no longer leave. You're stuck in this pancreas until I finish with you. Now inside the pancreas, there will be something called the citric acid cycle or the Krebs cycle that'll be going on. And that'll be producing a whole bunch of ATP. Now, I want to focus really quickly just on this diagram here. That's a measure of voltage. And what you can see is that outside the cell, there's a higher potential for it to be a positively charged environment. And inside the cell, there's a higher potential for it to be a negatively charged environment. And so what we're expecting is we expect a lot of positive things to be flowing inside the cell. However, the first thing that we see is this potassium channel happening right over here. Now, because we have potassium flowing from the negative side of the cell to the positive side of the cell, it's going against its gradient. And we can also see that with step 2 here, we're going to use some of the ATP that was produced from the citric acid cycle. And so this then would be active transport. To get the potassium outside of the cell. Now, once the potassium is outside of the cell, we have something that happens, it's down here at the bottom, called depolarization. What that depolarization will do is it'll create a large enough difference in the positive to negative side of the cell. So again, going back to this VM all the way over on the left-hand side here, it'll create a large enough difference between those two that depolarization will occur, and the calcium that's floating around outside the cell is going to want to flow from an area of high concentration to low concentration. So in other words, this would be passive transport. It still requires a transporter. And the reason that it requires a transporter is we are moving a charged substance across a non-polar membrane. And so we need to have a transporter to get it across that barrier. What it also allows us to do is control, or it allows the body to control how much calcium is outside and inside the cell and how quickly that calcium is moving around. It's a super, super nice system. Once we get the calcium moving inside the cell, that calcium is going to signal to these insulin granules, hey, we need to get this insulin outside of the cell. And that'll happen through phagocytosis. Phagocytosis. Once it leaves the cell, this insulin is going to enter the body, and it'll be secreted out, and it'll be delivered to all the cells that need the insulin. So there's a couple different treatments that exist then for this actual process. We have a couple different transporters. We have 3 of them. We have the glucose, the potassium, and the calcium transporters. All 3 of those would be targets for us if we wanted to treat diabetes. We have a depolarization event right here. And then we also have a fusion event, which is the ATP being fused, or the phosphate being fused to this glucose here. So there's 5 different opportunities for us to treat diabetes. One of the really common ones is looking at this potassium channel and trying to get that thing to close, which should hopefully increase the amount of calcium influx. Another one that they've tried is opening up this green calcium channel. The problem with that one is calcium is not a really good one to target because calcium is involved with the heart, also the nervous system, and also the muscles. So if you increase the amount of calcium flowing everywhere, you're going to have a lot of heart problems, potentially muscle problems, potentially nerve problems as well. The one that's being really focused on right now is this glucokinase. Trying to get this to be a better lock and key to the glucose to try and get it to lock the glucose down and keep it inside the cell. That's one way that we're really targeting type 2 diabetes right now. But this is just a brief example, kind of a relatable example, hopefully to you, of how passive transport and active transport and phagocytosis is used within the body very, very regularly, and how all 3 of those different concepts covered here are used to keep you alive and keep you well. I hope you enjoyed this. I hope this is interesting to you, and have a great rest of your day.